All right, everyone. Here we are with our second assignment here in Algebra, and it is on 1.2, solving multi-step equations. We're going to be looking at this first exploration where we have solving for the angle measures of a polygon. Now it says over here that the sum of the angle measurements of a polygon with n sides can be found by using this formula. S equals 180 multiplied by n minus 2. Now that's kind of a strange formula. You may have never seen something like that, but it's really not as, it's not as strange as you might think. All you really need to do is count how many corners your regular polygon has. This one has 3. Okay, subtract 2 from that. So 3 minus 2 is 1. 1 times 180, that's going to be equal to 180. So this triangle here, all of these angles are going to add up to 180. Over here on the side, we can just put a little bit of a cheat sheet and say that triangles add up to 180 degrees. Let's do that same thing for the quadrilateral over here. Quadrilateral means 4 sides. So we've got 1, 2, 3, 4 angles to look at. And 4 minus 2 is 2. 2 times 180 is 360. So in our cheat sheet, we can just write quadrilaterals add to 360, because you don't want to have to keep on doing this formula over and over again. What's the next shape we have? Right over here. This is a very, very slight 5-sided or 5-cornered figure. 1, 2, 3, 4 right over here, and 5 up over there. So this is a 5-cornered shape. That's called a pentagon. So we'll do this over here. 5 minus 2 is 3. 3 times 180. Well, that's 540. So pentagons add to 540. And then the last one over here, I'm sure, is going to be a 6-sided figure. Let's count the corners. 1, 2, 3, 4, 5, 6-sided figure. That's called a hexagon. 6 minus 2, that's going to be equal to 4, and 4 times 180, well, that's 720. So there we have it. Our cheat sheet's complete. We know that triangles all add up to 180. Quadrilaterals always add up to 360. We know that pentagons always add up to 540. And we know that hexagons always add up to 720. So we don't ever have to do that again. Let's take a look at our triangle. Now we know there are 3 angles, and those 3 angles have to add up to 180. So let's write an equation for that. Okay, we're not going to make it fancy or anything. It just says that angle 1 plus angle 2 plus angle 3 is equal to 180. Now that's going to be true for every triangle that we do. It's going to be true for triangle B, certainly. That's going to be true as well. But let's see what this triangle in A says. Now it says that angle 1, I don't know which one's angle 1, but let's just call this first one up here angle 1. Angle 1 is 30 plus x. Well, I don't know how much x is, but I know angle 1 is going to be 30 plus whatever number x is. Okay, also you're going to see that I've put parentheses around 30 plus x. That's a customary thing that we do when we substitute. It just kind of helps us keep everything together. Angle 2, that's easy. That's just a 30 over there. You're going to see that I substituted 30 with a parenthesis around it. Although since it's a single thing, you don't really need the parentheses around it. That's one of those other weird rules. Angle 3, I think you can see that's 9x, so let's substitute that. Okay. And the thing I want you to notice is that angle 1 here, that's the same as 30 plus x. Angle 2, that's the same thing as 30. And angle 3, that's the same thing as 9x. So that's what I mean by substituting. We're taking one quantity and we're exchanging it for something else, something a little bit more concrete usually. Okay, all of these things add up to 180. So remember what we were talking about in the last lesson. These two lines of algebra are equivalent equations. Okay, they have the same solution. Angle 1 plus angle 2 plus angle 3 equals 180. Well then 30 plus x plus 30 plus 9x has to equal 180. Now, we're supposed to simplify this, so we're supposed to go ahead and solve this. So here's what we're going to do to solve this. We're going to, first of all, let's get rid of all of those parentheses. We don't actually need them. And now we're going to identify these things by what we're going to call as like terms. And basically what you need to know is if it's just a number, then it's the same thing as anything else that's just a number. Those are the same type of things. We call that a constant. Typically when we do algebra, we try to associate the number in front of the constant with the number behind it, the sign in front of the constant with the number behind it. Now everything else has an x with it. You'll see there's the 9x and then the plus x. So those two things are also alike. They're alike because they have an x. Now we call that the linear terms because, well, because it's kind of a long story actually. So those are our linear terms. Our linear terms are the ones with the variable. Now you notice that I didn't highlight the 180 over here, and that's because 180 is on the other side of the equation from all of the variables. So it's kind of on the opposite side of all the good stuff. This is kind of what happens a lot in algebra. Now we're going to do something called combining like terms. And basically, if it's a constant, you can add it or subtract it to the other constant, depending on what it is. And then if you have linear terms, you can add those together as well. So let's start with the linear terms. We have 1x over here, and we have 9x's over here. Now I'm sure you've probably heard that if there's no number in front of that variable, you can pretend there's a 1 in front of it. So this is 1x and 9x. How many x's is that? Well, together they make 10 x's. And then we have a positive 30 and a positive 30. And if I add those together, I'm going to get 60. And of course, that's still going to be equal to 180. So we've gone ahead and we've created, now we have 3 lines. Each of these are equivalent equations. Okay. Now, there's an order that you have to simplify this, because we notice that we have a 10 times x and then a plus 60. And the order that you have to do things is kind of like the opposite of the order of operations. So usually with the order of operations, you would add last, but we want to add first. So we want to add this 60. Basically, you might want to think about it as it's the furthest thing away from the x, because the 10 is kind of stuck onto the x. So there's definitely a few different ways of looking at it, and I'm just trying to introduce them to you. But if you have 10 times x plus 60, you want to deal with that 60 first. So since it's plus 60, the inverse operation is minus 60. So here we are, we're going to subtract 60 from both sides of the equal sign. That gives us a 0 pair on the left side of the equal sign. I've done that in green, so that's a 0 pair. And if I write an equation that's equivalent to this, that's going to be 10x equals 180. Now I'm kind of running out of room here, so I'm just going to move over to the next, to the side here. So we've got 10x equals 180. And what I notice now is that this is 10 times x. So what's the inverse operation of times x? Well, that's going to be divide by 10. So I'm going to divide both sides of the equal sign by 10. Remember, the way that we're going to do that in algebra is you're going to put that fraction 1/10 on the outside of a parenthesis, and that's going to be 1/10 times 10. That creates a multiplicative inverse right here. And on the left side, all I'm going to have is an x. And then 180 divided by 10, that's just 18. I'm going to remind you again, if you're not comfortable making all these divisions, grab a calculator. So this was really our first in-depth problem here that we're doing in algebra. And that took quite a while, actually, about 10 minutes to kind of explain all the way through it to here. So hopefully the next one is not going to take as long. Let's see what we have. Yeah, let's look at letter D. Now we have 1, 2, 3, 4 angles, and my cheat sheet over here says that the quadrilateral adds up to 360. So if I add all three of these angles together, I should get 360. So let's put them all together. The first one is x minus 17. Okay. The second angle is x plus 35. That next angle is x plus 42. And the last angle there is just x. That's going to add up to 360. So, I don't see any subtracting of terms here. I did forget a plus sign here. I don't see any subtracting of things here. I know that's a minus 17, but that's inside the parenthesis. I don't see any subtractions outside the parentheses, so I don't really need them. Let's get rid of them right now. Okay, that looks a lot more manageable. So let's identify next our linear terms. And our linear terms here are going to be this x right there, this x right here, this x here, and this x over here. Now none of those x's have a number stuck to them, so we're to interpret that as 1x. So we've got 1x plus 1x plus 1x plus 1x. To my way of thinking, that's 4 x's. And then we'll take a look at the constant terms. Okay, that's minus 17, plus 35, and plus 42. Let's do this over here. Minus 17, plus 35, plus 42. We'll do that on our calculator, and that gives me a 60. Now that is a positive 60, and I want to emphasize that as well. Sometimes my computer does kind of crazy things. So that's a positive 60. So we're just going to put a plus 60 over here. And that's still going to equal 360. Now, these two equations that we wrote, the first line and the second line, those are equivalent equations. Now, the first thing we're going to do is deal with the constant term. The constant term is, again, plus 60. So we're going to subtract 60 from both sides. Remember, when I say from both sides, I mean from the left side of the equal sign, and then also to put a minus 60 on the right side of the equal sign. Now, luckily for us, we have ourselves a zero pair. Now, I say lucky for us, but that's really the whole point here. We're purposely trying to make that zero pair all along. We're trying to zero the constant term on the same side as the variable. So that's going to turn to 0, everything in green. And on the right side, I just have 360 minus 60. And I'll do that with a calculator. Minus 60, that's just equal to 300. Now that gives me 4x equals 300. And now I got to do something about that 4. And the thing to do there is interpret that as 4 times x equals 300. And the inverse operation of multiplying is dividing. So we need to divide by 4. Okay. Over here on the side with my calculator, I can see that 300 divided by 4 is 75. And over here on the left side, I can see that I've created a multiplicative inverse. So that's going to be 1. So on the left side, we get x. On the right side, we get 75. So x is equal to 75. Now that was like supposed to be an exploration, but really that was just kind of doing algebra. This is how we're going to solve multi-step equations. Now this is drawing a multi-step equation. We can skip all of this over here. How can we use multi-step equations to solve real-life problems? Well, that's the whole point of algebra right there. So we're going to skip that. We talked about inverse operations last time, and I'm not sure why we have the mean, but this is basically the same thing as the average. And in order to do that, we're going to add all the numbers together. And then we're going to divide. We're going to divide by the number of numbers. So to solve a multi-step equation, the first thing we want to do is simplify the equation, if necessary, and then use inverse operations to do something that you're going to hear over and over again, but probably from someone else, because I don't like saying this at all, but we're supposed to isolate the variable. And what that means is we want to get an equation that says the variable, let's say it's x equals something. So over here we'll write x equals something, or maybe y equals something. I don't know what the variable is, and it doesn't really matter, but that's how we want to do this. Now, some notes. The first note that I want you to think about is, first of all, you want to, the first thing you want to do, look for the variable. Identify, is a variable is it on the left or the right side of the equal sign? It's important that you always keep track of where that equal sign is. Then, if there's a constant on the same side as the variable, remember the constant is that number that is not stuck to the variable. You want to use an additive inverse to create a zero pair with that number. Next, and usually the last step here, if the variable has a coefficient, you want to divide both sides by that coefficient. Now we haven't used that term yet, the term coefficient. A lot of times when we do equations, or when we solve equations, we like to give the reasons for why we're doing things. So this is kind of a beginning of that. So on the left side here, you've got the equation, and on the right side, you have the explanation. So this is the very first problem we did today, and the equation was 30 plus x plus 30 plus 9x equals 180. And the explanation is usually write the word given. In other words, this was the problem. So what was the next thing we did? Well, we combined like terms. We did 30 plus 30 was 60, and then the 9x plus x was 10x. Now, whenever we do that, whenever we combine like terms, we say that that term we just simplified. So that's what we did there. The next explanation is simplify. So this, when you read this, you say, well, how come if this is true, this line was true, why is this line true? This line is true because we simplified. Now, in this scenario, what we have here, this will be a good place for us to identify where is the constant term. Our constant term is the 60, and then the next thing is where is the coefficient. So the coefficient is a number stuck to the variable, so our coefficient here is 10. Now I'm not going to bother solving this because we already did that, but I will show you the explanations. In the next step, we subtracted 60 from both sides of the equal sign, and we call that the additive property. Now I know we actually subtracted, So you could call this a subtractive property, and you'd be equally correct. But we're going to use the additive property. The next thing we're going to do is simplify. That's when we actually do some arithmetic, or we combine like terms. We get 10x equals 120. The next thing we did was multiply both sides by 1/10, or divide by 10. That's the multiplicative property. And that brings us to x equals 12, which was simplified. Now I realized that, just now I realized, the equation that I used was not the same thing as we had earlier in this lesson. So we're going to have to adjust this, but that's basically the idea here. Anyways, the rest of this is going to be some extra practice, and we'll take a look at that on our next video.